Good morning. I have one slide. I don't know if it's available. It's not going to be as pretty and eloquent as some of the others, and I'll try to drive through some key topics as I present to you all. But the most importantly, I want to keep. There should be one slide that I provided. It's really not that impressive, so if it doesn't pop up, it's quite all right. Here we are. So I do want to keep it simple as cybersecurity is, right? Everybody believes that? Yes. Okay. Well, kind of black and white, all shades of gray. Really, all shades of gray. Nothing is certain. But what is certain is all of you are here for a purpose, hopefully to find out the best practices in cybersecurity, the best vendors on cybersecurity, and how you can implement them in your own environments. So about me, Nathan Faith, I'm the Corporate Cybersecurity Manager in Physical Security for the nuclear generation arm of Exelon. Exelon owns numerous energy companies. One of them may be in your backyard. You may be supporting Exelon, and I say thank you for that. My role in the nuclear fleet is to ensure the compliance liaison is substantially there. In the 14 nuclear power plants that I oversee for the governance and oversight aspects is in regards to how we're regulated. Nuclear is regulated by the Nuclear Regulatory Commission, and there is a federal law, Code of Federal Regulations, 73.54, as Sid had mentioned. So with Exelon's fleet of reactors, it's the largest in the US. We have 23 total. That's a combination of boiling water reactors and pressurized water reactors. So I'll consider them not the new build, not the light water reactors that you're hearing about or the small modular reactors you're hearing about, but the tried and true, truly resilient and safe, clean, reliable power nuclear generation reactors that we have in the US fleet. A colleague on the panel here and from Duke Energy has one of the next largest fleets. So it's, while you may be speaking to the electrical perspective, he certainly does have a large stakehold in nuclear power in the US. One of the things that I want to do here is kind of turn back the clock. In nuclear power, it's yesterday's technology tomorrow. So my simple message to you is, in regulations or in providing security solutions, remember that legacy is important too. The motto in nuclear is yesterday's technology tomorrow. And what that means to me specifically is, while there's cutting edge cybersecurity solutions out there and brand new high-fangled Internet of Things devices, it's the small, discrete devices that may be considered digital, or they may be all the way into large, robust distributed control systems that require security, require cybersecurity, and the focus shouldn't be on the 4th generation operating system or the firmware level PC. It needs to be all of it, legacy all the way up until to the advances of tomorrow. What we have in the nuclear industry to cover that gamut of devices is a cybersecurity plan that's been approved by the Nuclear Regulatory Commission. It's based on the principles and the frameworks at the time. We started doing this after a voluntary initiative on sound cybersecurity practices. We got more prescribed nature driven by the regulatory framework of the Nuclear Regulatory Commission towards the NIST base. So the NIST base that we were working towards was 800 TAC 53. And as was mentioned previously with FSMA, the challenge there is IT components that FSMA is architected towards, and NIST 800 TAC 53 is architected towards, does not lend to an operational technology or industrial control systems environment. So that became a big challenge for the nuclear industry, and what we did was we predated the NIST 800 TAC 82 model of industrial control system cybersecurity best practices, and we tailored the NIST 800 TAC 53 controls to meet our needs. We took the controls that would apply to industrial control systems, tailored them to say how we could implement them, and if we couldn't implement them, what we would do as a compensatory measure or a mitigation factor, also known as operational and management and alternative controls. The industry template that evolved out of that and was approved by the NRC for usage is NEI 0809 revision 6. It's recently gone through some addendums, but it's a sister document, almost a twin sister document to NRC Regulatory Guide 5.71. 5.71 is very prescriptive. So if your organization were to take 5.71 and implement it, that's what you would do. You would do it chapter and verse, word for word, and if not, you'd have to explain as to why. The unfortunate issue with this compliance-based cybersecurity plan is that it's not risk-based. It's you will address all of the controls in the framework, and if not, why and why not? And most importantly, the only reason you're not going to is because that attack pathway or vector does not exist. What we've learned through implementing this over the years is compliance-based security is simply not that. Compliance does not drive what I consider cybersecurity. Compliance drives achievement. It doesn't drive acceptability of true cybersecurity. And what I mean by that is the checklist approach, it gives a metrics for completion, but not a metric for capability. So the not risk-based approach has been somewhat alleviated by the Nuclear Regulatory Commission, where they understand that not every device has the same attack surface, same attack vector, and quite frankly, the same attacker appeal. Why would someone want to attack a desktop calculator on an operator's control system when they could clearly go for a bigger bang for their attack buck, so to speak? So what I wanted to touch on today, again, is the major challenges that we have. It's really an ever-evolving threat, challenging the design basis threat. That's one thing that nuclear is very unique. We have a design basis threat. We have a subset of attack scenarios, attacker capabilities, and attacker characteristics. And that information is somewhat classified. It's one step lower than secret classified US government information. So I can't go into detail with it, but it is available to those with the need to know and those with the proper vetting. But it's ever evolving. The threat of today, tomorrow could be surpassed 10 times over. The attacker capabilities, could have taken 2 years to develop, and then, as we heard earlier, it could be automated to the point of script kiddie nature. While the nuclear industry and the power sector in the US is not required to defend against a nation state, an act of terror, so to speak, that doesn't mean that we aren't capable of preparing and identifying, reacting, recovering, and mitigating those types of attacks. We have a paramilitary physical security force, and we have well-vetted cybersecurity individuals implementing cybersecurity at our nuclear power plants, not just within Exelon, but within Duke and the other organizations that have cybersecurity requirements, regulation. So what is one of the major trends that I'm concerned about? Well, vulnerability disclosures. Hyper and over-centralized issues drive a continuous rat race and drive the cybersecurity professionals' focus away from protecting what's truly important than protecting against what the latest hypothetical proof of concept might be out there in the wild. With nuclear power, we're highly segregated from the business networks, the World Wide Web, using unidirectional gateways. So one of the items that the DHS spoke about earlier with making sure your networks are segregated, nuclear is there. We've been there since before 2012. Every nuclear power plant in the US industry committed to segregating and isolating our safety, important safety, security, and emergency preparedness systems to the matter of what they need to be protected against for that defense in depth position. We do have emergency preparedness systems outside of the unidirectional gateway, obviously, for continuity of operations, and most of all, for the safety and health of the health and public. And the biggest development I can see is efficiencies and high assurance of adequate protection, meaning we realize that we don't have to defend against the utmost determined adversary, but we should be able to demonstrate that we could if called upon. And the regulation doesn't account for that. The regulation is performance-based, but it holds you to adequate protection with high assurance. High assurance has been ruled as reasonable assurance. So what does that mean at the end of the day? Well, you have to have a cybersecurity plan, you have to have a cybersecurity incident response team, you have to drill that team, and you have to report on cybersecurity events. A little bit different than the previous discussion on, do you know what an incident is versus an event? An event is something that we're federally required to report to the Nuclear Regulatory Commission that says, we had a cyber incident. It was an attack. It did have an adverse impact on one of our safety or security systems. That's within 1 hour. sometimes within 15 minutes. Within 4 hours, it is, we had an attack, it could have caused an adverse impact, it did not cause an adverse impact. 8 hours, we believe there was an adversary that was attempting to cause an adverse impact. And then if there was anything else in our cybersecurity plan that we had a performance deficiency in, we're required to keep that on record and available for inspection at any time. And that has to be done within 24 hours, documented. So I welcome audience participation in the panel questions. I hope that you've gained something from this. And again, the simple message is this technology is the same throughout all of these environments, but don't solely focus on all the new and emerging technologies. Remember that legacy technology also requires your cybersecurity attention, focus, and supply chain management from the vendors. Thank you.